Hey everybody, and thanks for tuning in to today's webinar with Panorama Consulting Group. Today we're going to discuss how digital transformation can improve equipment management. Today we have the pleasure of speaking with Mohan, Head of Digital Transformation at Ramco Systems Limited. Thanks for joining us today, Mohan.
Thank you, Justin, and good morning and good evening to everyone, wherever you are.
Before we get started, we at Panorama want to thank the viewers of our webinars. So we will be giving away a free consulting session to the first 3 respondents after today's webinar. Stay tuned all the way to the end of this webinar to get some more information on this opportunity. With Panorama Consulting Group being an independent niche consulting firm, we specialize in business transformation and ERP system implementation for mid to large-size private and public sector organizations worldwide. We also specialize in OCM strategies and business process management, among many other solutions you can see here. The biggest industries we work alongside are within manufacturing, professional services, and technology, but we also deal with many sectors and clientele. Speaking of clients, our client portfolio includes many well-known local, national, and global customers across multiple industries. We also offer a deep and comprehensive ERP experience with hundreds of available packages that we have evaluated and implemented for our clients. So to get things started, Mohan, what are some of the concepts and trends you're seeing in the EAM function of various enterprises?
Thanks. So I would like to draw a parallel here before I jump into answering the question. So let us look at another asset which an enterprise has, which is the people. So when we want a job to get done, we make a job description, we make a specification of the individual we need to hire, we do some interviews and maybe do some reference checks, and then we induct the employee and then measure his output and monitor the output and then maybe retire the person. So in a similar way, we hire an asset or we buy an asset, and there is a lot of process which goes on to getting the asset into existence. So we raise purchase requests, purchase orders, look at some demonstrations, and then we actually buy the asset, and then we install the asset and bring it into production. So there's a lot of process which goes into bringing the asset into existence. But there is another set of people who are only worried about the financial part of it. So there is a lot of transaction and rules regarding how it's valued and how it is depreciated, and all those logic has to be built into the reporting structure. When the asset is actually used, we need to know whether the asset is performing well, whether it is in a good state of repair, and how to keep it in that state. So we need to monitor the health of the asset. But finally, we need to look at whether the asset is being utilized and it is performing the role it's been bought for. But there is a set of people who are interested in keeping the mission running, so the periodic maintenance and planning for the periodic maintenance, or attending to it when it is broken down, etc. So there is a huge department which keeps the entire set of machinery in good repair. But then the management is worried about whether the assets are working and we are getting the standard output. So we need to measure the output of the machinery, and sometimes not only one machine, but a set of machines or an assembly line or a factory, etc. It is possible that some machinery are too sophisticated for the in-house maintenance team, so the maintenance could be outsourced. It is also possible that some machinery are too expensive or not worth buying, but you can just lease it. And there are companies who specialize in leasing out assets and making their business in leasing out and maintaining. So if you look at all this, there is a lot of work, work involved in all these things, and It's not that we don't know what to do, it's just that the sheer volume of getting these things done is what has been the prime focus, I would say, in the last 50 years or so. But just to get this thing done, and to give an example, just to know that we have all the assets we are supposed to have itself could take months, because you have a crane, you have a laptop, you have some tools, and these tools could be costing $1 million, for example, in the aircraft industry. So everything has to be accounted for, any losses recorded and investigated, and so it's a very huge exercise. So this has become a very important and the basic thing which needs to be done. So technology is playing a major role in this part. However, if you do all these things, it's just that the machine is working as it's supposed to be working. Nothing more, nothing less. So we need to look at the next level. The next level is related to the planning part of it. So this machinery or this assembly line is there. It's supposed to produce something based on certain orders, which the company might have, or it might be making to stock. But whatever it is, there is a plan, and the machinery have to be aligned so that the plan of what is to be produced is really produced. And it's not that when we want to produce something, the machinery is having a downtime, or some other problem there. So the entire asset has to be integrated to the planning, and the planning has to know that this machinery is indeed capable of producing what it's supposed to produce at that time. And then we need to report whether what we planned and what's actually is going on fine. And also we need to analyze whether the machine has produced efficiently. That means it has taken the right amount of power, or the right amount of people, or the right amount of hours, or the overheads, all those things, whether it's been efficient in producing. So this has come to the next level, where the first level was mainly transactional, just to get those things done. But this level is an integration to the entire organization, not just to the assets at all. So we could look at this as the analytical, the part of this enterprise asset management. Moving on to the next level, it is one thing to get the machine operating and produce something, but it's a totally different thing. The machine starts speaking to us what it's doing. So it starts to tell its vibration levels, its power consumption, maybe it's heating up somewhere, maybe it's vibrating somewhere more than normal. All this will be done in real time, and it's very important in many industries. For example, the cement industry or any chemical industry, where the quality of the output depends upon the various parameters of the machine, the temperature of the machine, or any other process parameter. So it's very important that the machine communicates what the parameters are, and then instantaneous decisions can be taken, one to be within the quality range, or maybe to prevent a catastrophic failure, or maybe even in the long run predict that this this machine may require some maintenance a few months down the line. So it's important to know what this is, the machine talking to us. So the machine communicates, and there's a lot of technology enabled, from a simple Internet of Things, IoT, industrial IoT sensors, to right down to SCADAs and PLCs. So this we can say as the communication layer. But then we can go one level higher, and we can talk about the machine is talking not only to us, but the machine is talking and getting inputs from us after talking, and we are sort of collaborating. So it's either a machine to machine collaboration or a machine to human collaboration, and they form one team. And the way in which you interact, the way in which a human interacts, maybe in augmented reality or a virtual reality, or it could also be what's a digital twin, where uh, a computer model with all the algorithms is built into the computer, and it mimics the exact way in which the machine is actually behaving, and thereby what will happen to it, and when it needs to be serviced, or when it needs to be, downtime, and all those things will be predicted on the model. So there is a lot of research going on and a lot of models being built. In fact, many manufacturers are selling their digital twin along with the machinery, so that things can be monitored. And this is especially important in very critical areas. For example, an aircraft engine. So an aircraft engine got a lot of algorithms and predictive behavior built in, and then based on whether the flight took off on this temperature and was there a bird hit, and all those things are taken into account to predict when that jet engine needs to be serviced. It's also another trend where the machine collaborates with the human, or with another machine, or with the computer, and it gets a feedback loop, and it knows that if these are the input parameters, or this is the quality of the raw material which has been coming in, and this is the atmospheric conditions, then the quality output is going to be so much, and thereby I need to adjust some other input process parameters here to be within that process. So it's a feedback loop, and the production quality is maintained. So especially useful in process industry. So if you see what I have mentioned here, the lowest level was just to get the machinery working, and the second level was integrating the plans of the organization with the plan of the machinery. Then the machine starts communicating, and then the machine start collaborating. So the first part is action by the human, and the second part is the action by the machine. With this background, I think your question was, what are the trends we are seeing in the enterprise asset management? Predictably so, a lot of software and technology has been built around the first part. Traditionally, what was early to come was the finance part. So how do you depreciate an asset? What are the formulas and things like that, and asset counting and things like that. Many mundane tasks have been automated. For example, a barcode is there to quickly know whether what this machine is about, or it could be an active RFID to actually it will actually beacon that I am indeed here, and things like that. So many mundane tasks have been automated. And there is a lot of artificial intelligence on maintenance schedule. So previously it used to be a time-based schedule, and then it became a usage-based schedule, and then it became a condition-based schedule, and then it became all the digital twin sort of a concept. But the maintenance schedules have been tweaked to have the best output with the least amount of downtime. For outsourced maintenance and leasing, this requires a lot of collaboration between companies, and this is where a very strong ERP or some such thing plays a big part. So it is one thing to say that the machine would actually signal that 3 months down the line I need the spares, but this company needs to raise a purchase order on to another company to actually get those spares or tell the outsourced maintenance team to come and actually do that repair. So a lot of trends are coming in this where the machines actually raise their own purchase requests and purchase orders, and the people just approve these things. So this part is the most difficult part, the bottom part, because there's a lot of action, there's a lot of automation, and there's a lot of checks and balances, and most of the money goes in this part of it. But if you look at the analytical part of it, the integration to planning and the reporting, it's been a bit sketchy here, partly because it's quite difficult to do a planning even for the sales, and because that is another chapter by itself, where the sales planning is also dependent upon a forecast, and it's also dependent upon other models. So the machinery being integrated to these plans is there. It's there. It's not a problem of the technology. It's more about the people getting around what the right plan should be. But if you look at the other two, it's a fully technology area. So industrial engineering, giving every millisecond some parameter, and that is going into some huge database, and that's being analyzed in real time and communicated over a 5G network. I mean, these things are quite, it may look very high-tech and science fiction, but it's actually quite simple, and even college grads or even lower can actually do this programming and get these things up and running in almost a week or so. But the place where the first level is between human and machine collaboration and machine to machine collaboration involves a lot of capital investment, and that would really be required only when the company's business outcome depends upon it. For example, there is a huge logistics department which needs to fulfill the orders within, say, a 10-minute or something like that after an order is placed, and some things have to be picked up from various shelves and put into a package, and it needs to be packed and it needs to be shipped. This company really requires some thousands of automated vehicles going here and there and picking up stuff. But I don't think this scenario will really work out for a company which is a manufacturing automobile parts. That really won't work. What the automobile parts manufacturer would be more interested in is producing some parts just in time and things like that. So maybe it's not really there. So the trend and the topmost thing on the first and the second level is that the technology is there, but the people, the usage of it, it says it depends upon various factors, like whether it's really useful and whether it really brings a competitive advantage to them.
All right. So with a lot of concepts going on here, which is great. Thank you so much for explaining that. So what are some of the business challenges with these concepts in mind that facility management companies are facing?
The business challenges are, peculiarly nothing to do with technology. It is figuring out what to do. This may sound counterintuitive, but it is really difficult to figure out what makes sense in our company setup. So is it that we need to manage the assets better, or is it that we change the business model by these assets, or these assets are just to be maintained at a particular level of efficiency and we need not worry about it. So the business challenges are these: how much money do we have to spend on keeping the assets running, and do we need it for a competitive advantage? The business challenges companies normally face are which assets also need to be done, because when you take a factory setup, there will be thousands of assets, but only 2 or 3 would be really critical and will be on the critical path. For example, an automobile manufacturing company would have thousands of assets around it, but the assembly line is the critical part. So anything which improves the efficiency and the uptime of the assembly line would be the most critical. So the business challenges are mainly here. So I have a set of capex for this, and where do I need to put it in, and what exactly do I need to do it for? The other business challenge which the companies face is to actually figure out how to do it. So the how to do it part, there are a lot of vendors who promise that they would operate in any one of these 4 levels. But the real challenge is, unless the lower parts are done, the higher parts are not, easy to do. So unless you have an ERP system, or you have the basics of asset monitoring, or all those basic things, like whether it's integrated to planning, whether you have it's not possible to start using our assets to have the digital twin and things like that. So there are 2 challenges: what to do and how to do it. So the how to do it part also involves a lot of work. For example, you need a single system for the planning part, for the sales part, for the assets part, for the finance part, for the purchasing. You need a single system ideally, which is not, it's not a batch process to move from one system to the other, and then you lose all the sense of real time here. So there is a lot of work. Even most companies do not have a single system for their entire ERP. They have 3 or 4, and how to integrate that itself is a big challenge. So there are 2 issues, as I said. One is what to do and how to do it.
Okay, so the what and how, you kind of touched a little bit on technology earlier. What role would that happen to play in EAM specifically?
Right. So EAM is absolutely required in EAM in the current context, and many of the advances are entirely driven by technology. The lower part, the transactional part, could be managed by people by putting an army of people to actually figure out whether the assets are there and things like that. But after a certain point of time, it's not possible to figure out which asset is breaking down, which asset is having a problem, which asset will break down. These are things which are impossible for the manual the persons to manage this part of it. Even monitoring is difficult, but forget about prediction. So technology plays a huge role as you go up the ladder. So when you go up to communication and also prediction and predictive based maintenance, technology plays a huge role. But again, coming back, that can be done only when the lower levels are done. So
All right.
if you want, I can give some examples on where in the lower levels it's done.
Yeah, please.
Sure. So some examples on how the lower levels, for example, an asset needs, you need to know whether the asset really exists. So given a very nice example, when you go in the air, when you fly in the aircraft and a set of people get down and the next set of people have to get in, this time has to be the shortest. But the aircraft by mandate needs to verify that a certain set of objects are there in the aircraft. For example, the air safety bags need to be there. The or a set of medical equipment needs to be there. All those kits need to be there. So how do you do this in the fastest time? So they figured out that you can put some RFID chips at each one of those things, and a person just walks by with a meter, and he just walks along the aircraft, and it actually counts the number of objects there. And then at the end of the thing says, yes, we do really have. So there is a high level of automation and a high level of robotic process automation in this area of transactional things. The asset health and asset monitoring, etc., are available as dashboards, and all these things are pretty much very much standard, and they're being offered by the equipment manufacturers themselves to see whether things are going well.
Awesome. Thanks for those examples. So in every industry, there's always kind of a hype of technology versus what people think of it and then what's actually used in reality. So what kind of digital technologies are actually being used in EAMs around the world?
Right. There is actually no one technology which is hype and the other one is not a hype. It's actually specific, it's context specific to the industry or the actual company being used. What's a hype to one company may be a reality to another company. For example, if I talk about interconnected unmanned vehicles, packaging stuff, it would be it might be okay to an Amazon or a Walmart, but it doesn't make much sense for a small manufacturer making some automobile parts. It won't make much difference. But what makes much sense to an automobile, say I was talking to a CEO of an automobile dealer network manager, and for him the biggest issue was, how do I train the set of people who are going to service my car, and the turnover rate of the technicians is also large. So training a person to service the car would also be a long time. So he was very happy with an augmented reality or a virtual reality type of a training. And when he's actually doing the service in an augmented reality, uh, the system actually tells you that which part is not good, it doesn't look good, or it needs this service. So training for a service is a very important step for one set of companies, but this makes no sense to somebody in another industry. So I think the hype the hype is definitely there in some technologies, but again it has to be context specific. But in general, I would say that augmented reality and virtual reality have not lived up to the extent we thought it would, and that is somewhat in the hype area, except for some areas like this training and automobile repair. And there is also a little bit of hype between a human and a machine interaction. I think right now it's more like the machines work on a set of jobs by themselves, and the people work on some other set of job by themselves on an assembly line. But it's very rare that a human and a machine, it's not like the science fiction movies where the man and the machine walk along each other. I don't think that has happened. It's like a hype. But otherwise, everything else which I talked about, like the industrial IoTs, the SCADA, the PLCs, they're very much in use, and it's not a hype at all.
Awesome. Okay. So let's tie all this up really. So how does EAM tie into and really tie up the overall digital transformation of an enterprise?
Right. So I think that requires to define what digital transformation is in the first place. So we do have 8 principles of digital transformation, but that's another thing. But there are 3 things actually. there is what is called digitization, there is digitalization, and there is digital transformation. There are three things, and we need to differentiate between them. So digitization is just getting everything from paper onto the system. So we don't have any paper anywhere, and there is no manual data entry. So you know, everything is there on the system. So that is just digitization. It could get a few percentage points of benefit, but that's digitization. Of course, it's required. It's not that it's not, we can do away with it, but it's not going to give you much benefit. Digitalization, on the other hand, involves the process to be run by the computer. So it does some workflows, it does some analysis, it takes data from automatically from where it's supposed to be taken. For example, it takes you walk into the office, it sees your face, and then it says, okay, Mr. X is there, and this is his work, and then it gives the work to him. So the computer drives the work and the process. That's digitalization. This could enhance a lot of efficiencies, but that's still not digital transformation. It just makes things faster of what you are doing in the first place. Digital transformation, on the other hand, is to change your business model totally. So for example, if you were selling air conditioners, you say, okay, I'm not actually selling air conditioners. I'm selling you air at 25 degrees centigrade for so much tons of air or something like that. You have changed the business model, and that is going to give you a benefit. So if you take the first two, the first digitization would maybe give you 10% benefit depending upon how much you are actually manual. Digitalization maybe give you another 20%. But a digital transformation, on the other hand, is actually 3 times, 10 times, maybe, depending on what is the idea you come out with. So if you talk of the first step as a caterpillar crawling, and then the caterpillar crawls faster, a digital transformation is the caterpillar actually becoming a butterfly, right? And if you're talking about digital EIM to do digital transformation, if that is the question, then we have to see what part the asset actually plays in this whole in the whole company and the whole output. Sometimes the asset is just an underlying thing, and any improvement on the asset is not going to actually improve the product itself, in which case then it's not really worth to spend too much on the asset. But sometimes the asset becomes the main thing for the transformation, and then that is really going to give you a lot of business benefit. To give some examples, if you're okay, I'll take two examples, one in the textile industry and one in the automobile industry. In the automobile industry, the margins are so thin that if you actually have 5% scrap, then you are already lost your profitability for the month. So if you want to reduce the scrap, then what you need to do is you need to monitor. Say you're producing an automobile, chassis. Then you need some. It is possible to have a web camera which is in real time monitoring all the scratches on your on scratches and any dimples and any other defects on the metal in real time, and it will tell you at the painting shop itself that there is a problem here. You can go back and rectify it, instead of it going to the customer and then coming back. So if you install this web camera, which by itself is not a great deal, it's a very inexpensive thing, but this will really digitally transform the business. But this would not make much sense to another industry. In the textile industry, for example, the output, the garment which comes out is not a very costly item by itself. But what's more important is very quickly to change the fashion, the model, and the cut. So somebody is in Hong Kong and he is producing some shirt or some skirt or something like that to somebody in Europe, and the person in Europe actually does some designs. And to agree for the design itself, if you send drawings and pictures, it takes months, it seems, take 3 months or so. If you're able to reduce this for 15 days, for example, by collaborating between people on the internet and seeing a 3D model of it, and not maybe much more than Zoom, a 3D immersive experience. You can bring it down to say 15 days. And that design is uploaded to the machine, and the machine instantaneously changes the garment. And it seems for various countries, you need different places where the button should go, and all sorts of variations happen. And if the machine is directly integrated with your computer on the sales order plan, now you're talking about doing production for multi countries and rolling it out. If it had been done manually, it would have been impossible to meet the deadline of the Christmas or whatever. So there you are. So in those 8 laws I was talking about, the third law is what says that you should take the bull by the horn. What I mean is the most important thing which will change your business is the thing you need to digitally transform. Unless that is done, if you look at some other peripheral thing, for example, you automate the payroll or something like that, it's not going to give you any benefit. So on your question, how does an EAM really digitally transform, digitally help in digital transformation? The answer to that is, first check out if an asset is really the one which is going to give you the business benefit, or it's going to be some other, maybe the sales or the financial model could be this thing. If it turns out that it's really the machinery which makes, for example, if you are making a 5 nanometer chip, well, it's really it is the machinery which is making that chip. So you need to really digitally transform the asset. If that is so, look at what's the most important thing to transform and then transform that. So that's where it is. And from my experience, the technology is not the problem. It's figuring out what to do. And then the technology is already there. I think this is the first time that the technology has far outstripped the demand or the use for the technology. So there is a lot of there is a lot of hammers waiting there, waiting for the right nail to hammer it with. So we really have a lot of solutions. We don't have the right questions.
So thanks. Like, I really appreciate your time, Mohan. All your advice, solutions, everything you've kind of given us so far. It does look like we have a couple of write-in questions from viewers here. So let me take a look through here. All right, looks like we have time for a couple of them. So the first one here is, what business benefits can one expect by using these digital technologies?
Well, as I said, in asset intensive industries, for example, a refinery or a cement plant, it's critical. It's almost dependent on how much uptime the machinery has. The business benefit could range anything from 5% to even 25%. There have been companies where the maintenance was outsourced, and they could reduce it by proactive communication, and they could reduce the number of visits. So I think that's a broad range, 5 to 25%, depending upon how manual you are to start with. These are the business benefits of increased uptime, lower maintenance cost, and more importantly, less energy consumption. In high process-driven industries, an inefficient motor or something like that could actually take up a lot of energy being wasted there.
Okay, so it looks like we have time for one more here then. Oh, this is a good one. So what does Ramco offer for equipment management?
All right. So Ramco has been in the ERP space for almost some 30, 35 years. And when we talked about those 4 levels, Ramco does all the 4th level excellently. So it's got all the finance, it's got all the purchasing, it's got all the asset details, it's got the way to install and maintain and do the predictive maintenance, the scheduled maintenance, all those things it does very well. When we come, and it's also integrated to the planning, and you can plan, and the plan of the machine comes up, and you can actually figure out whether if the machine is having a downtime, how do you change your plan. It does an MRP run, and all those things it takes care well. When it comes to the IoT and the integration to SCADA, we have a platform which can integrate any SCADA and PLC to Ramco. However, it does not store the millisecond to millisecond data. That would be a third-party system which analyzes. But what Ramco does is, based on an alert coming from that, it can proactively alert somebody, or it can raise a purchase request or a purchase order on some third-party person who's supposed to maintain it. On the higher level of digital twin and all the AR, VR, the equipment itself is not from Ramco. We have some hardware partners who can work with us and provide a total solution. And we also have a set of experts and also boutique partners who have the logic. So they have a set of algorithms which will actually know the quality of steel and the surface of the steel to detect a crack, things like that. So we have people who work on the specialist item things and provide a total solution. So what I'm saying is we have either we have a total solution, or ourselves, or we can partner with the hardware and some specialist partners to provide a total solution.
All right. Well, thank you so much for kind of answering those questions and really just for your time today, Ram.
Thank you. Thank you, Justin.
Alrighty. So to finish things up here, and for those who stay the entire time, we want to reward the first 3 respondents with a free consulting hour with our digital transformation experts. So go to panorama-consulting.com and enter the code free consultation along with filling out the how can we help section of the form. If you'd like to inquire about Panorama's comprehensive services, feel free to visit our website at panorama-consulting.com, or you can reach out directly to our Director of Innovation, Alan Salton, at alan.salton@panorama-consulting.com. Thanks again, everyone, and have a great rest of your day.